Hello, good morning, sir.
মর্নিং মর্নিং শোনা যাচ্ছে?
হ্যাঁ, শোনা যাচ্ছে।
আচ্ছা, ঠিক আছে।
দেখি একটু আর একটু wait করুন. Let the participants
হুম,
join and the streaming will start. Okay, a few more minutes.
ওকে।
Oh, hello, Orkendu.
এখন প্রেজেন্টেশন দেখা যাচ্ছে?
Yes, madam.
হ্যাঁ, প্রেজেন্টেশন। হ্যাঁ, দেখা যাচ্ছে প্রেজেন্টেশন। বলছি অর্কেন্দু একটু আমাকে
Yes,
জানিও স্ট্রিমিংটা কখন স্টার্ট হচ্ছে আর একটা
আমি
জিনিস হচ্ছে একটু ইউটিউব লিংকটা একটু দেবে আজকের ইউটিউব লিংকটা।
আমি দিয়ে দিচ্ছি ইউটিউব লিংকটা দিয়ে দিচ্ছি আর স্ট্রিমিং স্টার্ট করে রেখেছি আমি।
আচ্ছা, তাই তবুও একটু
হ্যাঁ।
মানে পার্টিসিপেন্টসরা জয়েন করলে একটু জয় করবো। আর তো কিছুক্ষণ বাকি আছে, 10টা এখনো বাজেনি। আপনি
হুম।
আহ, আমাকে একটু মেলে পাঠিয়েও আমি তাহলে ওটা দিয়ে ঢুকে যাবো। ইউটিউবটাও একটু দেখবো। একটু
ওকে
ইউটিউব
ওকে
লিংকটা।
ওকে ম্যাডাম।
হ্যাঁ, ঠিক আছে। Hello, participants have joined. Orkendu, I'm
আমি
unable to open the YouTube.
I'm checking.
Actually,
It's only 10 participants have joined.
Okay, perhaps they will be joining more. Let me start introduction then. Okay.
Yes, yes.
Hello. Good morning
Yes,
to
ma'am.
all participants. And good morning, sir. So today, in the morning of Independence Day, Happy Independence Day to all. And today is the final day of our STTP short-term training program. So our distinguished speaker today is Professor Dr. Prithviraj Purkai. So before the session starts, I would take the privilege of reading out a short profile of him. Professor Purkait has received his graduation, master's, and PhD in electrical engineering from Jadavpur University in 1996, 1999, 2002, respectively. He was a design engineer with Mrs. Crompton Grips Limited, Mumbai, India, for 1 year. During 2002, 2003, 2005, and 2007, he was a postdoctoral researcher and a visiting academic with the University of Queensland, Brisbane, Australia. From 1998 to 2019, he was a full-time faculty with the Department of Electrical Engineering, Haldia Institute of Technology, and St. Thomas College of Engineering and Technology, Kolkata. Presently, he is professor in the Department of Power Engineering, Jadavpur University. He has authored as well as co-authored about 100 research papers and 5 books. His present research interests includes renewable energy integration issues in hybrid smart grid infrastructure, fault diagnosis and condition assessment techniques for conventional and renewable energy electrical equipment, as well as advanced signal processing applications in power engineering. So now the session is all yours, Professor Dr. Purkai. Please start your lecture, sir.
Thank you, Nobamita, for the nice introduction. At the beginning, I should thank in Narula Institute of Technology for providing me this opportunity to interact with the participants of this STTP, and of course, Nobamita for keeping in touch in these tough times. The topic for discussion today that I have chosen is in line with the theme of the STTP. So, it's IoT-based smart energy meter, specifically for use in hybrid smart grid when we talk about integration of renewable energy sources or in general distributed generation. The way I wish to proceed today is that initially I'll give some introductory topics like the Indian power scenario, where the renewable energy share stands now, and those renewable energy, whether we are going to use it standalone by itself or we are going to integrate it with the grid. That means the concept of distributed generation, and then Government of India initiatives for integration of the distributed generation. And as an integral part of such integrated grid with distributed generation, I will introduce smart grid, features of smart grid, why smart grid is essential for integration of distributed generation into the grid, different ICT and IT infrastructures that are necessary for smart grid, and then I will move on to the actual topic of today's discussion is smart energy meters, which is definitely a part of our smart grid infrastructure when I talk about smart grid with distributed generation. Next, I will discuss about a case study where we developed IoT-based smart energy meter using Arduino microcontroller and Wi-Fi and GSM modules. The different development stages. I will start with a very short comparison between the smart energy meter versus the conventional energy meter that we know. I will discuss about the block diagrams, the different components that we used, and the circuit diagram, and finish it off with the performance analysis of the developed smart energy meter and the future scopes. To end today's talk, I will touch upon the smart meter deployment in India, where we stand in India, how much is the smart meter being used or planned to be used, and then I will highlight finally on some other applications of IoT in a smart grid infrastructure. So to start with, I will go with the Indian power scenario. This is old data. It's 2017 data that I have with me now. As we can see, 59%, almost 60% of the power generation is in India. In 2017 was still from coal. But the encouraging thing is the second highest, around 17%, which amounts to 57 gigawatt out of the total 327 gigawatt power developed, power generated were from renewable energy sources. So you see, a good share of the total power that's developed in generated in India is from renewable energy sources. So not only that, the target is to generate 175 gigawatt of installed renewable energy by 2022. That means almost three times or even more increase in the renewable energy. So that's a huge amount of renewable energy share that we are expecting to be fed into the total power grid. So keeping in view the target, a large amount of renewable energy share in the total power system, what we look towards is, shall we be using those huge share of renewable energy sources by itself alone in distributed manner, or shall we be connecting them to the grid? So then comes the question of large scale integration of renewable energy to the grid. That means the concept of distributed generation. So why this concept keen is that day by day we are looking towards reducing or lowering the dependence of our system on the fossil fuels like coal and all, and the enhanced electricity production from the renewable energy sources. If we look global scenario, the global energy consumption supplied by renewable energy sources was around 19-20% in 2015, which in 1 year's time grew to about 25%. And projection is that the growth is to reach an 80% level by 2050. So 80% of the total global energy generation will be from renewable energy sources. So such a large share of renewable energy sources is not problem free. So it has got its own problems like unpredictability, because we know the renewable energy sources like solar and wind, they are very much dependent on the environmental conditions. So as soon as there is a fluctuation in the sun or the wind profile, there will be a fluctuation in the renewable energy produced. So, with such a huge share of such unpredictable amount of energy being fed to the grid, the traditional centralized structure of the electrical power system, by centralized structure I mean there will be a generating station which will be giving power to the consumers around. So that's a centralized power system structure. So that may not be suitable with the 80% share of unpredictable renewable energy sources being connected to the grid. So the conventional centralized structure of the power grid no longer may remain suitable. So in such case, the distributed energy resources, they cover a fundamental role for enabling the smart power system. So we cannot continue with the traditional power systems. We need to transit to a smart power system. So when you talk about such distributed energy resources, they are actually a combination of energy storage systems like large scale batteries or other storage devices, renewable energy sources, and of course conventional power plants. So all of them together will be a part of the distributed energy resource or the distributed generation system. Consumers, which in a smart power system we also call prosumers, because they produce electricity as well. So consumers or prosumers with multiple distributed energy resources, they will have their own distributed energy resource, like they can have their own rooftop solar power system, and or with energy storage systems, they will all be coordinated to form a integrated energy systems. So examples of such integrated energy systems with distributed generation and storage systems are like microgrids, say virtual power plants. So my apartment can be a power plant with rooftop solar, energy hubs where you have community generation of local electricity, and multi-energy systems where you have a number of such systems being connected to a smaller microgrid. So with this concept, the government of India, they took recently, they have taken some very positive initiatives for integration of some distributed generating resources or distributed resources into the grid. So they have set up a high level technical committee in the year 2015 for various issues relating to the large scale integration of distributed generation. The recommendations from the technical committee was in several actions, like bringing flexibility in the conventional generation. So during the week, during the month, the energy production need to vary according to the need and according to the share being given by the renewable energy sources. Frequency control is one of the major issues that is linked with some distributed energy resources or the integration of distributed generation, because as soon as the generation or the load level unbalance, there is an unbalance between them, the frequency is going to vary. Then maintaining generation reserves like storage systems. So I should have some storage system and also some reserve that like contingency cases, whether how much I can put them in to maintain a balance between supply and demand. Major issue when we talk about renewable energy sources being integrated to the grid is forecasting. You need very fast and accurate forecasting, not only in terms of power, but definitely in terms of the environmental conditions. Scheduling of the load and generation, short-term scheduling, and peak demand management. And then all of these integration of forecasting, scheduling, control, maintaining or balancing generation, they require a very fast and accurate or robust data telemetry, means communication between all the stakeholders of the grid system. So that high level committee, along with these recommendations, they also emphasized on few points like establishment of renewable energy management centers, like they need to be all to be integrated in the grid, and augmentation and strengthening of the transmission system, because it's no longer a centralized transmission system. You have different points of feeding power to the grid. Distributed energy sources will be connected to the grid, so the transmission system needs to be strong, not in terms of power only, in terms of communication also. And of course, compliance to regulations and standards of renewable generation, like renewable energy that is generated by the distributed resources, they need to be under one standardized level of generation. Like I cannot go in the market and buy 100 rupees worth of solar panel, a small solar panel, and connect it to the grid. So that has to be certain standardized technical specifications for those to be connected to the grid. So in more details, what are the initiatives is, as I was telling in the previous slide, there will be renewable energy management centers. So there mainly their job will be forecasting of the renewable energy sources, SCADA for renewable energy generation. So you need to monitor and control the renewable energy generation, and scheduling is definitely a part of the renewable energy that is being generated. In addition to the generation of renewable energy centers, you need energy storage systems. So the energy storage system management centers, they will have testing and develop deployment of different energy storage technologies and balancing and maintaining them with the generation and demand. There will be setting up of green energy corridors where you will have the conventional sources being integrated with renewable energy sources. So integration of renewable energy through strong grid connections, and they will enlarge the balancing areas, right? So in our home, in our locality, in our ward or in our city, the load and generation that can be balanced without fully being dependent on the centralized generation. So in our city, if it's a microgrid structure, we can have, in locality, if it's a microgrid structure, we can have local balancing of the load and the renewable energy or the distributed energy generation. So to ensure such a wider area balancing of load, we need wide area measurement for better visualization of the grid parameters. So be the main grid or the microgrid. So you need to monitor all the parameters of the grid in real time so that the stable operation of grid is achieved. And this will enable the situational awareness and supervision. So the managers of the grid or the microgrid need to be aware of the situation and supervise the operation of such a grid. And then in demand response pilots means balancing between the load and the generation, distributed generation. We need some monitoring device. So a major component of such a monitoring device or actuator even in this case is the automated or the smart energy meter. So that's one of the major components in all of these activities. And such a system, the demand response pilot, can have a price incentives, means the tariff can be varied according to the load demand or according to the time of the day. So by varying the tariff also, we can do load scheduling or demand side management. So all these components of the initiatives that are being put forward for smart grid and distributed generation integration are actually potential areas of research and development. So all of these five big points that I have given, if anyone is willing to do a research in this area, say a PhD or master's degree or even undergraduate project may be a part of this, so they can note this down, and these can be a very good area of research in India. This is being under development, and it's very interesting to know that many of these are actually making use of the theme of the HTTP. So these renewable energy management centers, they use extensive use of microcontrollers and all, like an IoT, because they are all internet net connected. So energy storage system management, they also require microcontrollers. The energy corridors, the integration, they require the intervention of IoT and microcontroller. The wide area measurement for grid measurement and grid monitoring, they will also require the intervention of IoT or application of microcontrollers. And the smart energy meters and price tariff variation, they also require IoT and microcontrollers. So all of these activities that are being taken up as pilot project from the government of India for integration of DG, they require extensive use of this microcontroller technology and IoT technology. So in Indian scenario, if we talk about the development of smart grid, which is necessary for integration of the renewable energy sources or the distributed generation system, the vision of India on smart grid is to, I will read this through, is to transform the Indian power sector into a secure, adaptive, sustainable, and digitally enabled ecosystem that provides reliable and quality energy to all with active participation of stakeholders. By stakeholders, here I mean the generation system, the transmission system, as well as the consumers. So all of them together, they are a part of the stakeholders of a smart grid system in India. So with this in view, with this in vision, the Ministry of Power, Government of India in 2015, they have constituted the National Smart Grid Mission, a body that is entrusted to plan and monitor the implementation of policies and programs related to smart grid activities in India. So that NSGM is the body right now under in Government of India who takes care of these smart grid development in India. So according to them, according to NSGM, the definition of smart grid goes like smart grid is an electrical grid. So means it's a conventional grid, power grid plus something enhanced conventional grid. It's an electrical grid with the added concepts of automation, communication, and IT systems. So you have integration of electronic communication, you have integration of information technology and instrumentation automation that can monitor power flows from generation to consumption and control the power flow to match load with generation in real time or in near real time. So these very effective communication system, automation and IT infrastructure, they are going to make this like online very fast. So smart grids can be achieved by implementing efficient transmission and distribution systems, system operations, consumer integration, and renewable energy integration. So the essential components of smart grid can be implemented by efficient transmission distribution systems, operation and control of those systems, and integration of renewable energy, distributed generation, and also integration of the consumers into the grid. So this diagram of smart grid I had shown in one of my previous presentations with NIT is the concept of smart grid. You can see on the left hand side, you can see the conventional power generation system. Then you have the control center. In addition to the conventional power system, in a smart grid infrastructure, you will have the renewable energy sources like solar and wind, the other distributed generation components like battery storage system. You can have electric vehicles, then you can have smart buildings, smart hospitals, our houses, industries, and smart office buildings. So all of them will be a part of the smart grid energy system. The blue dotted lines through them, all of them are indicative of the communication link that is used to communicate between all these components of a smart grid system. The line diagram of a smart distribution network will typically look like this, where you have the main grid here, main power grid, where you have the main power grid here. From the main power grid, you have through circuit breakers and sectionalizing switches, you have power being given to the microgrids. You can have a low voltage microgrid, you can have a medium voltage microgrid, like your apartment can be a low voltage microgrid, your locality or the town can be a medium voltage microgrid, and all of these microgrids will have the distributed generator systems. So these DG systems, they are distributed generator systems. They can be solar, wind, biomass, those kind of renewable energy sources, and also they will have the storage systems in them. So these micro grids or the distributed generation system, they are all connected together by these red dotted lines. You can see they are all communication links, and they are all connected to a SCADA system. So the activities of the National Smart Grid Mission for integration of the distributed generation systems to our normal grid listed like one of the major activities of them is the advanced metering infrastructure or smart energy meter that I was talking about, development and deployment of them. Then upgrading the normal substations that we have to be compliant with the smart grid infrastructure, especially deployment of gas insulated substations. Then promotion of distributed generation in the form of rooftop solar power photovoltaics. Then real-time monitoring and control of the distribution transformers and other devices connected to the distribution system. Infrastructure for supporting the proliferation of electric vehicles. So they will encourage the use of electric vehicles, development and use of electric vehicles, development of medium-sized microgrids, and provision for power quality improvement measures. So once again, all these points are under development of NSGM, and there is a good amount of funding from the government of India if you are going to do research on any one of these topics. So those who are planning to start or continue their research in this area, these are the target points where there is a good amount of funding from the government of India for funded projects and all. And the government of India through NSGM is promoting deployment of smart grid projects. So any project related to these topics under the NSGM through funding support of up to say 30% of the capital expenditure. Even sometimes other schemes can give you more funding also. So quickly, what are the features of smart grid and why we are dealing with a smart energy meter? Why we are talking about smart energy meter? So the salient features of smart grid, the first one is the bi-directional flow of power and information. Whereas conventional power grids are typically unidirectional, where you have flow of power from the generating station to the consumer. In a smart grid infrastructure, the flow of power will be both ways. Means conventionally, I will receive power from the main grid, and if I have the provision of solar generation in my rooftop house, I can also sell power to the grid. So as a consumer, I can also give out power or give power to the grid. So this is a two-way or bi-directional flow of power and definitely information also. Next point, the feature is the increased balance and flexibility. So the load and generation demand can be rapidly modified or balanced with each other, even under the uncertainty of renewable energy generation. So that's very fast forecasting and scheduling can do such balancing. Reduction of ATC losses means the technical and commercial losses means the power losses. Increased grid visibility and self-healing grids means there will be a lot of sensors being put into the smart grid infrastructure where you have almost an online view of the grid status. And self-healing grids means if you have a very fast acting automation system being installed, so such system can supposedly correct itself very quickly. You don't have to wait for 1 day or 2 days for the fault to be repaired. Very quickly the information comes and you can work upon. One major component of smart grid, as I told, is the advanced metering system or smart meters, which will enable real-time monitoring of the power flow. It will have the feature of in-house display. In your home, you can have display of the power, the quality of power you are consuming. You can view it through your mobile or through web portals. Through internet also, you can view the power consumption pattern in your home or your building or your industry. And the pricing mechanisms need to be dynamic. When you are talking about balancing the load and demand in a smart grid infrastructure, means you cannot rest upon a slab-based tariff. That has to be a dynamic tariff. And such features of smart grid will facilitate the connection of distributed energy sources to the grid. So they will allow movement and measurement of energy in both directions, from the consumer to the generation and from the generation to the consumers, through control systems and the smart energy meter. So that will help the prosumers, the consumers will also produce to safely connect to the grid. So how far India has progressed in its journey towards a smart grid is that since 2010, since the last 10 years, there has been 11 smart grid projects and one smart city project that is under development and implementation. So in 2013, the government of India, they published the first document on smart grid vision and roadmap. In 2015, the Bureau of Indian Standards, the BIS, they laid down the specifications and standards for smart energy meter. And then the smart grid regulations got approved from the Power Ministry, which is the standards and rules for smart grid deployment. A test bench, a test bed is under development by the CPRI, which will test smart grid and its components. A knowledge center is being developed by Power Grid on smart grid, and then functional specifications for smart energy meter was finalized and released by the BIS. So that's where we stand in deployment of smart grid and smart energy meters in India right now. So what are the components of ICT and IT in smart grid? So these are the major points. So once again, these are the topics of research where new researchers can really look upon. Is smart energy meter infrastructure, development and deployment and analysis. Peak load management, when you talk about distributed generation being connected to the grid, peak load management is one of the major issues. Then power quality management, because the smart infrastructure and renewable energy systems, when they are integrated with the grid, there will be a lot of power electronic components that will be required. And as we all know, the power electronic components, whenever they are integrated to the power system, they will have the questionable harmonics or the power quality issues. So management of those issues, outage management, which is a part of the load balancing mechanism, then deployment, monitoring and control of microgrids and distributed generation. So research on any one of these topics is going to do good in future or present researchers. So next we move on to what we mean by a smart energy meter, why it is a part of our smart grid, why it is an essential part of our smart grid. So advanced metering infrastructure, smart meters or AMI, it facilitates monitoring and measurement of consumer information and also control through smart meters installed at consumer premises. So the energy meters that we have right now installed at our home, it will replace that by a smart energy meter. So that will have monitoring and measurement of the information, not only the active energy, but other forms of energy related parameters that will be monitored in both ways, like the consumers also can view and of course the supplier can also view. So the smart energy meter, it supports bi-directional flow of power and information. The conventional meters, they can only measure the power you are consuming. But if you are a potential source of power generation, like you have a solar rooftop, so those smart meters can also measure how much power you are feeding back to the grid. So it supports bi-directional flow of power and information between the consumer and the utility control center through communication modes such as GPRS, Wi-Fi, radio frequency, or power line carrier PLC. So smart meters are also used for renewable energy integration or rooftop solar integration. So net metering, internet-based metering that is being deployed, which uses bi-directional meters that can record the export to power with how much power we're exporting to the grid. So those smart meters, in addition to collecting data for the active energy we are using, can also record data on power quality, power outages, how many times in the day or how many hours in the day you are having load shedding or power outages, the active power factor, reactive power, total power, apparent power, in addition to grid voltage and frequency. So they are more versatile. So the data, the large amount of data the smart meter does collects can be used for improving the renewable resource forecasting. So if you have such large amount of data at your disposal, you can very well use that data for forecasting purpose. So what better distribution generation, better demand response. And smart meters will also enable, when you have such smart features in the energy meter, will also enable the additional features of pricing and billing, such as time of use, TOU pricing, and critical peak pricing or real time pricing. So the smart energy meter will have all those additional features which our current meters do not have. So diagram how a smart energy meter will enable will support the bidirectional uh, energy metering. You have your house which is having a rooftop solar power in it, and you have the smart meter here. So your house is connected to the main grid, main power grid. So from the main power grid, you are drawing power, normal power. But the solar panel that you have installed, the distributed generation system that you have installed in your home, can also give power to your home. So you can use that power. And if you have any excess of that power, you can feed that power back to the main grid. So in that way, the bidirectional meter will measure the total usage, how much you are taking from the grid, and how much you are giving back to the grid, and in what time of the day you are exchanging such kind of power. So when it's the power demand is very high, what you can do, you can use more of your own generation so that you consume less from the grid, so you pay less to the grid. And in cases when say you are not in your home, you have gone away somewhere, so whatever power you develop, you can sell it back to the grid. So in that way, you can also get a less amount of energy billing. So in that way, the bidirectional meter can help you in performing all this effort. So now I move on to the case study that I was talking about. So this case study about is about development of an IoT based smart energy meter using Arduino microcontroller and Wi-Fi and GSM module. So this work was a part of a undergraduate electrical engineering project that we did a couple of years back, and this was presented at the IEEE conference. So this work is still under development. So we have built only an initial prototype of a smart energy meter and tried to study its performance with, of course, the limited resources that a UG student will get. So in very short, we all know about this conventional energy meter. So it's also called a watt hour meter or a normal energy meter, be it the normal disk type, induction type energy meter, or the um, nowadays we are using digital meters. Anyway, they are all such conventional energy meters. So they are an instrument which measure the amount of electrical energy we use. So it's also called the kilowatt hour meter because we measure the kilowatt in how much kilowatt we have consumed over an hour. and we call it 1 unit of energy. So what these meters do actually, they measure the instantaneous voltage and current and calculate their product to get the instantaneous power. And this instantaneous power, when integrated over a certain period of time, will give us the energy. That's how conventional meters they work in principle. There are certain loopholes in the conventional energy meter, which is leading us towards development of smart energy meter, which we plan to implement in a smart grid infrastructure, which has distributed generation integrated with it. So the first and obvious loophole of conventional energy meter to be used in smart grid is that it cannot measure bidirectional flow of power. So the induction disk will not rotate in opposite direction if you are giving power back to the grid. So that's a major disadvantage of using these conventional meters when I want to integrate my home with a smart grid. And it's not easily reprogrammable. So it's not programmable. Once they install, you cannot change it. The energy calculation process or the pricing and the billing process so easily. There is always a chance of human error while taking the meter reading because it's a human dependent. Somebody will come and check the readings. There is no verification process for the meter reading. We rarely go down under the stairs in our meter box room and check whether the electricity person has taken the readings properly. We just look at our bill after 3 months and we always get surprised why it is so high. We never bother to go down and really check. And it's also not possible all the time to go and check. So this not in terms of only verify the bill, and also we are not very ready to verify how much power you are consuming, say in a daily basis or in a weekly basis, because it's not that convenient. And there is always a chance of theft and corruption in both ways. The consumer can also do tampering with the meter, and the suppliers can also do something that the meter reading. Few weeks back there was a dispute in the billing system that came out in the newspapers. So those things can happen. And of course, human power is required because somebody has to come and take the readings. And consumers are not readily updated of his usage. You rarely will get to know that whether you're using the more amount of power today or this week you have used too much of power. So there is no record. Only after 3 months you get your energy bill. And it happens sometimes that the consumer will not be getting his bill in due time, in time. So nowadays you can check your bill online, but earlier days I have seen the printed bill coming late and having to pay fine. So those things did happen. So these loopholes in the conventional energy meter has promoted the development of smart energy meter to be used in smart grid with distributed generation. So the objectives of the smart energy meter that we try to develop under the fourth, fourth year project, undergraduate project, was that the meter should be having the facility to read and record the energy consumption data and communicate it with the control center in real time. So it will be online, it will record and communicate the energy consumption immediately and communicate it with the control center. So the control center, upon receiving the data, can send the instantaneous values of the meter readings to the consumer and to the suppliers also through either Wi-Fi, through SMS, or even through IoT, means through internet also. So the energy meter that we plan to develop is was supposed to have the features of prepaid metering. It's like a prepaid our mobile, so you pay early earlier, and then according to your balance, you can consume your energy. So you have a check on the amount of energy you are consuming. Along with the energy you are consuming, the energy meter that we developed is to have some other information, like it can record the values of power factor, it can measure the record the values of active, reactive, and apparent power, it can record harmonics, and it can record power outages, how many hours in a day you are having load shedding. The energy meter that we developed, obviously, So that has some features like eliminating the existing problems with the conventional energy meter, such as chances of theft and corruption, because it's all online. So very rarely you will have a chance to tamper with the meter. Immediately there will be discrepancy, and that will be noted down. And since it's all automated and online, nobody has to come and take the meter reading. So it's the human effort is also reduced. The technologies that we utilized for development of the smart energy meter was a Wi-Fi module. Then another module we had a GSM module which will send SMS. We had IoT through internet. It was being transmitted to the consumer and the load center. And we had the Arduino microcontroller as a hardware device to be connected to be as a part of the smart energy meter. So the block diagram of the smart energy meter when it was using a GSM module was very simple. It looked very simple. You have the power source, the AC source. You have the AC source. Then you step it down through CT and PT. Being, uh, it's being fed to the load, and through there you have a tapping of CT and PT, which through the microcontroller you process the data. The data can be immediately displayed through an LCD module, and the data can be sent to your mobile phone through SMS through a GSM module. And then the relay was used to, when we had the provision of prepaid metering, means when your balance goes out, the relay will switch off the power to the load. That was the block diagram with the GSM module. The block diagram with the Wi-Fi module is very similar. Same, you have the CT and PT being feeding power to the microcontroller, and the power is being fed to the load. You have the provision of LCD display, and then through a Wi-Fi module, you send the data to cloud, and from the cloud, you can download the data in your mobile or in your laptop or PC. So there also, it's a provision for online display and monitoring of the power that you are using, the profile of the data that you are recording. The components that we used for developing the smart energy meter are very simple components. So I have listed only the major ones, like we used Arduino, microcontroller. We had a Wi-Fi module. In another module, we had the GSM module. Then CT, PT, voltage regulator, and LCD displays. There were a few other things also, like relay and buzzer and other protection equipments, devices that I have not included. So the software that we used is Proteus for simulation of the microcontroller before actually building it in hardware. Arduino IDE, which was to load the data into the microcontroller, and the cloud server, which was used to store the data in cloud. The schematic circuit diagram in Proteus, those who are using Proteus on any other microcontroller simulation package, they will know this. So this is a pictorial diagram of the circuit. You have the microcontroller here. You have the LCD, here you have the relay, here the CT and PT. Then we have a buzzer, sensors, they are also used. This one I suppose is with the Wi-Fi module. The previous one was with the GSM. Yes, this one is with the Wi-Fi module. The circuit diagram with the Wi-Fi module. The previous diagram was with the GSM module. So if you want to have a look at the hardware model, this is a very familiar model. You ask your fourth year students to submit their project. So this is how they will bring and submit during the day of the Viva. Pathetic way of presenting. Then we had to give them a repeat date to make the hardware look better. And after 2 days, somehow they could manage to fit everything within this plastic box with a jack outside and display on the top. So this looked a bit better. So I asked them to give it a form of a actual looking energy meter so I can sell, and this is what they brought me. Anyway, that's better than the previous model which was brought to us during the first day of the final year Viva. So the some results I will show what was being displayed. this was what was being displayed in the LCD panel, the energy. So the load was not a big load. That was a lab load that was having 10 or 10 bulbs. Machine lab, we have those bulb load systems. So that was being used. Some small amount of energy, but anyway, that's what it displayed. Uh, the data, as I was telling, it was put into the cloud and could be downloaded in your laptop or computer. So in a web browser, these results were also deeply displayed. So when you change the power demand by switching on the loads one at a time. So that's how the real power changed over time. How the apparent power that was also recorded, how that was being changed over time. The energy consumption, how that changed when we switched on or switched off some load. We had RLC load variation was possible. So, and then we had the record of the power factor also. So all these components of the power supply could be recorded and displayed in online real time. So those results can also be displayed in a mobile app that the students developed during their project. So in a mobile app, you can have a record of the energy and power and all those parameters that you were recording. The voltage and current display have shown there are other parameters also that it could display in your mobile app. Some of the salient features of the smart energy meter that was developed, I will list a few. So the consumer with the energy meter that we developed, it was shown that the consumer as well as the service provider, the supplier is able to view and read the energy pattern along with the respective amount. So how much energy you're using and in which pattern during the day, during the hours of the day, you can view. So in that way, you can have a check or how you're using the energy throughout the day. So that data, which is collected by the data management system, it can give us energy usage information to the user through the internet. So when I go out of my house, I expected that the switches and other things will be shut down, so energy demand should be low. But I can still, if I find that the energy demand is high, I will know that I have forgotten to switch off some devices. So then that I can keep a check on the energy usage that is being done. The device always works online, so all the data are received in real time. So that's a good advantage of the energy meter that it's always connected to the net, is always online. So the measured parameters are visible both in web page as well as in mobile app. And with the help of the developed mobile app, one can view day-wise load analysis curve along with current collected load data to the energy meter. So power optimization can also be achieved. If I have a knowledge of the pattern of energy consumption throughout the day, I can somehow manage the uh, optimization process. So means at a time when the demand is high, so I should not switch on too many devices at a time. Maybe I will schedule my washing machine, then I will schedule my pump, then I will schedule the AC, so that the energy demand doesn't go or take a peak at one time of the day. I will schedule the devices, the load. That means I can go towards optimizing my energy usage so that I do not reach a peak at a given point of time. Because very soon that type of energy pricing is going to come where you have to pay more if you consume during the peak hours of the day. Few more features of the energy meters. So through this energy meter and the data we upload in the cloud through the control center, the service provider can keep track of the energy consumption pattern. So in that way, they will have a provision for better and efficient load forecasting and load management systems. As a service provider, the power supply company also need to know what is the pattern of consumption of the consumers they are supplying to. So through these huge amount of data and online data that the energy meters, the smart energy meters will be providing, the supply company or the control center can have a very authentic forecasting and scheduling management technique. That will also enable them to have or determine the peak loads period and the time when it occurs, and thus load scheduling becomes much easier for them. The Android app that we could develop is directly connects the user to the supplier. So through that app, the supplier can communicate with the consumer or the consumer can communicate with the supplier. So thus each and every consumer becomes a part or a contributor to the energy management system. And when it's being stored, the data all being stored in a cloud server, it is supposed to be more secured. And transparency will increase because what I was telling, it's not possible for me always to go downstairs under the stairs to check the actual energy meter reading when we have conventional energy meters. But when it comes to my mobile, through a single click, I can check the energy consumption patterns. So there is a transparency that will increase since human involvement is not done. So I don't have to depend on a person from the utility to come and take the readings. I can myself check the energy consumption pattern. And since it's online, so it's all the time updated, so there is no delay in the billing process. And the developed energy meter that we develop, it has the feature of prepaid metering. So you have a certain amount of balance, you know how much energy you can use. If you want, you can recharge, or if you are going for a holiday, you don't have to recharge. You can keep it at bay for 1 week or 2 weeks before you can recharge again. We planned some developments in the design, which all of are facing. The fourth year students, it's very difficult to get them to work all the time with the project. So we had some unfinished job, which we planned to be doing in future. And the major, one of the major things that remain, which we are planning to do, is the system can be enhanced for power theft detection using IoT. So some programming or some devices can it be connected to the smart energy meter. So if there is some pilferage or theft of power somewhere in between or in the consumer premises, whether that can be detected by the energy meter, and that will reduce the total ATC losses for the supply company. Unfortunately, the meter that we developed, we did not find time to check its bidirectional power recording facilities. So we did develop, but that was not properly tested. So that needed to be tested whether it can measure bidirectional flow of power. Smart billing system that will have a very variable rate of energy consumption depending on the time when you are consuming the power. So that is still to be incorporated. We are planning to include this option also, like we have online payment of our mobile, so that if that also can be done, whether when we can have online payment through the mobile app itself. So the prepaid energy meter, whether that can be recharged like we recharge our mobile phones. So in the model that we developed, we had load analysis of a single entity, means the load that we only connected. So we were thinking about whether we can add some features to the smart meter where it can do load analysis for a wider area, say for the apartment, whether it can do the load analysis or whether it can do load analysis for a say locality. Then the scheduling or the forecasting will become much easier. And we require serious further research on improving the security features because it's connected to the grid and to the internet, and there is a always a threat of cyber security. So there can be hackers coming into the energy meter and altering the energy meter readings or even intruding into the power system operations. So the cyber security space, cyber security of the smart grid infrastructure is a big area of research in recent times. So that was about the meter that we developed. Then we were interested in how these meters are being deployed in India. So there are several government initiatives and policies for deployment and development of smart grid projects in India. So they had a program called APDRP program, the Structured Accelerated Power Development and Reforms program. So that in addition to the Central Electricity Authority, they had taken up this project of smart meter development and deployment in India. So in 2015, the size of energy metering market was approximately 340 40 million US dollars, and that is expected to grow at a growth rate of 8 to 10% over the next 4 to 5 years. And the government of India have started a scheme, Uday scheme, a scheme for operation and financial turnaround of the DISCOMs, distribution companies. So these distribution companies, they estimated to install 35 million smart meters by the year 2019 in and around India. So not only that, India is producing and deploying the smart energy meters throughout India, they are in fact exporting also. So India is exporting over 400,000, means 4 lakhs energy meters to Australia, followed by some 50,000 meters to countries like Malaysia, UK, and even the UAE. So India is not only developing it for its own use, it is exporting smart energy meters also. So I will share one success story that came up in the NSGM before. That was about a town Tundla in the UP. So before energy meter was installed, so it was before 2015. So before the energy meter was installed, and then after the smart energy meters were installed, these lines is about, these bars are about the revenue, how much revenue the power company collected, and this green blue line is the how much is the losses, the ATC losses. So you see, before the energy meters was installed, the revenue generation was quite low. Not all energy could be billed or metered properly, and the losses were quite high. But after the smart energy meter were installed, the revenue generation was increasing at a good rate. Not only that, the power losses, not power loss, the ATC losses, the technical and commercial losses, they also went down. So because it was more transparent and all the energy consumption, the theft could be reduced, and also after installing smart energy meters, that's how the profile increased. So that's how the DISCOM, the distributed energy, distributed distribution companies can gain through this deployment of smart energy meters. So, lastly, I will talk about other IoT applications apart from smart energy meters, smart meters. There are other IoT applications which, as a researcher or even as a MTech or final year project, people can think about. Is in this area, like health monitoring and predictive maintenance of all the components being connected to a smart grid, forecasting and analysis, remote monitoring of the power system components and outage management, optimization of power system uh, components, renewable energy integration, big issue, safety and security of the grid, and also the internet connection, the cyber security issues. Then enhancement of customer experience and control, means power quality issues and availability of smart meters data for energy analytics, means forecasting and all, how better you can use the smart meter data. And the technologies that are being used for integrating IoT with smart grid and smart energy meter. Some of these are like Zigbee and power line communication, then broadband, RF, Wi-Fi, even mobile technology like GSM, then normal Ethernet, FTP, and LP WANs also. I'm not an expert on these topics, but these are being used. I used in the part of this in the project that I did. So thus, finally, what I will say that there's a large scope, a huge scope of multidisciplinary research in this area of smart grid with distributed generation and the application of microcontroller and IoT in this area. Thank you very much, Naumika.
Thank you, sir, for such a nice presentation. There are few questions here in the chat box of YouTube. I request session coordinator Shubhra Madam, please read out the question.
Yes, madam. Thank you, sir. The question is it possible to replace whole existing system with smart grid system? If yes, then what are the challenges?
You don't have to replace the existing grid with a smart grid. The first point is you don't have to replace whatever grid you have. You have to add additional components to it. Like many places, you have to add sensors and all, and then you have to add communication system, communication modules with it. That communication will not be a wired communication. That can be through internet also. There's not much of an infrastructural change that you have to make. But if you are looking towards the future, we have to look for renewable energy sources which need to be integrated with the grid, and that becomes a smart grid. So when it comes to smart grid development, the things that we need to do is to add automation, communication, and IT systems with the existing power grid, and that is one of the challenge. Then the next channel comes that the transmission and distribution systems, they need to be compatible with for bidirectional flow of power. Smart energy meters need to be installed. There will be questions about the stability because we are using renewable energy sources which are intermittent in nature. So power system stability need to be analyzed, power quality issues need to be analyzed and looked upon, and we need to have those smart energy meters installed. So though it is challenging, but it's the future, and globally it's going towards it, and in India also. Last 10 years we are moving towards it in a slow pace, but now the pace has picked up. Next.
Existing transmission line can be used for sending power to grid from consumer end produced by DC, or we have to make separate network for doing same.
No, the existing network will be sufficient because whatever power we develop locally, say through the renewable energy sources, like solar, they produce DC. Wind, they produce AC, but with variable voltage and frequency level. So we have to use some kind of a converter inverter system to convert the DC power through solar or the variable AC power through wind or other sources and make them suitable to be connected to the existing grid. So there will be a power electronic device which will convert the DC produced by a solar panel to a suitable AC to be connected to the existing grid, and wind also we need a converter inverter system to make convert the power to suitable level to be connected to the existing grid. So we don't need a separate network. The existing power system network will be used for bidirectional flow of power, but we need a converter inverter system.
Thank you, sir. Next question is, for controlling of national grid system, how data from cloud? How data from cloud?
How data from cloud?
Uh, For controlling of national grid system, how data from cloud?
Hmm.
Hello.
Which cloud?
I think this question was raised by Professor Fonar.
Sir,
Sir, can you please? Yes, can you please, sir? I would request. Can you please read out the question once again? I think the question appears to be incomplete here. Sir, are you there? Hello, sir, are you there? I don't think sir is joined. Uh, Perhaps sir is in the YouTube. Sir, is the question appears complete to you, Dr. Purkar?
Something is missing.
Yeah,
Anyway, what I
yes, sir.
understood that if you can upload the data that the smart meter records to a document cloud, means the cloud, the internet, then the control center or the consumer or the controller or the supplier can download that data as per their, you know, that will definitely be password protected and all secured. And then you can use that data for monitoring and control of the grid infrastructure. Yes, it can be downloaded.
Next question is, if there is a cross connect bill generated, then how we recover from that situation?
If a wrong electricity bill is generated,
A cross connect bill. If there is
cross
cross
connect
connect
bill.
bill is generated, then how we recover from that situation?
Cross connect bill means somebody else's bills come to my house.
I think so.
They've
Share
written
the
the
bill with
question
your
in this way.
share the bill with your neighbor. That's what the cyber security issues, the security issues that need to be looked upon. So it has to be secured. So those are the concern of the IT people, not electrical people. I'm scared.
Thank you, sir.
Mm.
if there are no more questions, then I would request our corner of examination, who is also the professor of our department, to say a few words. Just take a few moments, Professor Porkai, because today is the final day, and he may have some question, as well as I would also request him to deliver the vote of thanks. Hello.
Navamisa, do you want me to deliver the vote of thanks or to say
Yes,
a
sir.
few
And
words?
also, sir, if you have any question, sir, deliver the vote of thanks, and also, sir, if you have any questions, sir, you can also
I think
ask.
I think Dr. Purkayat has covered this uh, area of smart metering in a very nice way. This, however, in the distribution sector, one side is the discoms. He has covered it from the point of view of the discoms. But in smart grid, there is another issue of the consumer end. Consumer end, there is a lot of IoT and smart applications, especially the HEMS systems or home energy management systems. Now, ready-made solutions are available by which you can, optimize the energy consumption at your home and operate all this. And also, these HEMS systems has some integration with the discoms energy management system. So you get your alerts in the computer, you get your whatever whenever your bill is becoming higher, so that your home energy management system is completely integrated with the discom smart meter and the discom systems. Well, I think otherwise Dr. Purkayat has covered it extremely well. He has covered all the other aspects of the smart metering and the communication systems, and also the you know uh, the distribution control center. Uh, uh, Thank you very much, Dr. Purkayat. This area is evolving, and this in this area there are so much research is going on, and every day we are getting new insights. I think you have thrown some insights, but we all have to look forward, because we will be very insignificant compared to the knowledge build up in the area of smart grid. I thank Dr. Purkayat very much in enlightening us with the concept of this new technology. Thank you.
Thank you, sir.
Thank you, sir, and thank you, Professor Purkai, for being with us. So, as a token of appreciation, I would share a certificate of appreciation in the screen. So, kindly just have a glimpse of it, and I would mail the same to you. As it appeared, is it visible?
Thank you. Thank you very much.
Okay, sir. So, thank you for sharing your precious time with us. And thank you to all the participants for being with us for this 6 days session. And you will be given a questionnaire after the completion of today. A set of questions kindly submitted in the stipulated time, and after which the certificates will be issued to you. So I would once again like to announce that our next phase of STTP will start from 27th August, second phase of short-term training program, as well as the third phase will be starting from 7th September. So I would expect all of you to join in those two sessions also, because some of the resource persons will be different and some will remain same, but there will be variations in the topics as well. So please be with us in future, and thank you to all the faculty and staff members, and to the entire organization of Narula Institute of Technology for your support and motivation for conduction of these programs. So with your permission, I'm closing the session, and also I am thankful to Professor Purkai. So goodbye, stay safe.